Hi, welcome back. So this is the second video about digital systems, and we're going to be going over number systems again. So we're just continuing it to give more ideas about it. So number systems continued. Okay. First idea is going to be parity bits. Parity bit is something that is a bit that's okay. First, I need to define a bit. A bit in binary is one digit in any code word, in any word. So it can be either 0 or 1. So that's a bit. It has two options. And so parity bit. So let's say something has 4 bits in it. So 0, 0, 1, 1. I'll make this a 1. So this has 4 bits in it. Okay? Let's say we want to add a parity bit. So this is how it works. We add 1 to the beginning. This is the parity bit in this case. There's two kinds of bits. There's data bits and parity bits. The parity bits assist the data bits. They can be used for different things, like to represent negative numbers, or to check for errors, or to check if the numbers are even or odd. The number of ones in a number is even or odd. So in this case, because there's 3 ones, therefore the parity bit is 1. So this gets a 1. If it were 1, 1, 1, 1, there's 4, which is even. So it gets a 0. So that's what a parity bit for checking if it's even is. Okay? It can also be, okay. Now I'm going to show a different way to use parity bits. So we can use parity bits to get negative numbers. The way we do this is the first way is sign value. This is the easiest way. The way you do it is just a 0 in the beginning equals positive. 1 in the beginning equals negative. So 1, 0, 0, 1 is when you're using 4 bits. This is the parity bit. And these are the data bits. So the answer is -1 in base 10. I made a mistake, hold on. Okay. Now we'll talk about 2's cont. This is a different way to represent negative numbers. So every time it's negative, will also be the same. However, it flips the bits. So 1, 0, 0. Hold on. So let's say we want to get negative 2 or negative 3. Negative 3. Okay. So 3 equals 1, 1. So plus the parity bit. So 0, 1, 1. That's 3. So negative 3 is going to be, we go for, basically we just flip all the bits. So it becomes a 1, 0, 0. And then we add 1. So it's 1, 0, 1. Okay? So 101 equals negative 3 in 2's count. Those are the two different ways to represent negative numbers. Okay. Next, we have carry. We already went over them, but I'll go in the last video, but I'll go over it again. Carry is, let's say we have 1, 0, 1, 1, 0, 1, and then 1, 0, 1, 0, 1, 0. So 0, no. So adding them is 1, 1, 1, 0. Here's the carry. This is the carry. And then this is, so it becomes 1. And this becomes 0, 1. So here's another carry. So that's the answer. That's what a carry is. Borrow is 1, 1, 1. And then 0, 1, 0. So minus, so we have 1 minus 0 is 1. 1 minus 1 is 0. 1 minus 0 is 1. Let's say we made it. Let's say we made it this. So 0 minus 1 is, we borrow from here. This becomes 0. This becomes 10. 1, 0 minus 1 is 1. So that's the answer. Okay? Now we have overflow. Overflow is when we have, let's say we were confined to a 4-bit output. So we have 1, 1, 1 plus 1, 1, 0, 0. So answer is 1, 1, 0, carry, 0, 1. We mark the overflow because we're only allowed to have 4 bits in the output, but we have an extra bit over here, so that's the overflow. Okay, now we're going to have something that might seem a little complicated, but it's really simple. This is called code word matrices. So let's say we have 1, 0, 1, 0, 1, 1, 1, 0, 0, 0, 1, 1, and 0, 1, 1, 0. Now let's put the parity bits over I'm not going to draw it because there's graph already. Let's put the parity bits over here, 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 here. So the words are, this is a word, and this is a word. So in all, there are going to be 8. There are going to be 8 different words. I think, yeah. Okay, so the parity bit for this one is 0 because there's an even number of ones. Here it's also 0, here it's 0, here it's 1 because there's odd number of ones. Now over here it's 0, 1, 0, 0. Okay, so let's say we want to, let's say I want to change, let's say when we change the data bits, they change the parity bits. This is the data. These are the parity bits. So, let's say I change, 3 are changed. So, how many parity bits are going to change? So there's different ways to do this. One is to do this. If all these are changed, so the parity bit, so this, let's say, so this becomes 0, this becomes 1, this becomes 0. Parity bit changes to 1. This changes to 1. This changes to 1. This changes to 1. So 4 bits have changed. Okay? I'll put it back to normal. Okay? I'm using the highlighter to mark which ones are getting flipped. Okay? There's other shapes you can do. There's this, which changes 2. It'll change this. I'll change this because there's an odd number of bits being changed. So it's going to change them. Over here, it doesn't get changed because there's even, so it doesn't change anything in this case. So blue is going to be 2. These are the parity changes. Alright, video's over.